Hello again, I'm Magnus. I like writing t-sql code, and I like the code to run fast. In a couple of previous videos, you can find them in the links or in the comments to this one. Anyway, I've shown a couple of use cases for so-called tally tables or numbers tables in t-sql. And then I got a remark from Jeff Moden saying to really show why we should use tally tables, I should showcase the difference in performance with other approaches. So that's what I'm going to show you today. So let's look at some code first. Here I have the first video I posted. It contained this piece of code. So what is this? Well, this is a way to generate all possible combinations of the letters A to Z to make up 4-letter strings or codes. So, and this is the tally table version of it. And what's the tally table in this case? Well, it's these numbers, where I use then the row number function to number them. So I get the numbers 1 to 26. And using that, I can produce the alphabet in a common table expression, which I then can reuse. So this is the tally table solution to generating strings. And as you can see, the strings that I'm generating are these ones. So all possible combinations of the letters A to Z in all 4 positions of a string, resulting in roughly 500,000 rows. So let's look at the next approach, which would be the loop-based approach. And here I have declared a couple of counters, the counter I, the counter J, the counter K, and the counter L. And then I have 4 loops. So while I is less than 26, while J is less than 26, K is less than 26, and L is less than 26. And then in the innermost loop, I insert into a temp table, because I can't really do a select in every loop step, because that would produce 1 result set per step of the loop. And we don't want Management Studio to receive 450,000 result sets. So I'm putting it into a temp table, and then by the end of it, I do a select from the temp table, and then I drop the table. To make this comparison fair, and this is a thing you should think about too when you use a loop-based approach, if you have to, use a transaction. So begin transaction, do all the steps in the loop, and then commit the transaction. And the reason for that is that if you don't explicitly start a transaction, then every statement, every insert statement in your loop will be a transaction on its own. And that means the log, the transaction log, has to be hardened with every statement. If you use a transaction, SQL Server can write into a memory buffer, and when that's full, that's going to be written to the transaction log. So it's a huge difference in performance if you use a transaction or not. So I wanted to make it fair, so I used a transaction. So that's the loop-based approach. The third approach I want to show you would be the recursive common table expression approach. If you have never worked with recursive common table expressions, they look a bit funky. I'm not going to go into depth. So if you want to know about recursive common table expressions, you have to look it up on your own. Or maybe I will post a video about them in the future. But I'm starting the same way with the recursive common table expression. I'm having the alphabet, CTE, which will produce, well, the alphabet, A to Z. And then in the recursive part, or in the recursive common table expression, I'm first selecting the data set from the alphabet CT. Okay? Then I have the recursive part where I select from the anchor part here, and then cross-joining to the alphabet CT. And do some string concatenation, and then I have this stop condition where the width of the anchor is less than the word length that I've defined, and I defined it as 4 in this example. And then in the outermost query, we do a select from the recursive CTE where the width of the string is whatever word length I have defined. So these are the 3 approaches. And I have told you before in previous videos that CTEs are, that the tally table approach or any set-based approach to the problem is probably faster than any other approach. And you may look at the recursive CTE and think that's a set-based approach, but really it is a loop-based approach. It's just that you don't define the loop in itself with a while or for clause. You define it as a recursive common table expression, but that in itself is a loop-based approach. Anyway, what I've done is I have run this code for the 3 different approaches, for 2-letter strings, for 3-letter strings, 4, 5, and 6-letter strings. And I've timed it. So let's look at the timings first for the tally table over here. So as you can see, if you look in the left corner down here, let's zoom into it. So if you look here, this bubble is a little bigger than the other bubbles. That's because these are the 2, 3, and 4-letter strings. They time around 0 on this scale, where I have seconds on the y-axis. But you can see a linear progression. So with the number of rows produced, you have a linear progression of the execution time. That is good. You do not want to have a shape looking like this of the graph, because that means that you have a kind of exponential growth in time that it takes to execute the query. Anyway, that's the tally table approach. Let's look at the same timings for the loop-based and the recursive CTE approach. So let's start with a loop. It is also a linear progression. And it kind of makes sense, because if we would look at the tally table approach and look at the execution plan for it, it will be loops, running inside loops, But the key difference is that when they are running as part of the execution plan as a nested loop join, SQL Server does it. And SQL Server will do it a lot faster with the compiled code that the SQL Server engine is running, as opposed to the interpreted t-sql code. So t-sql is not the language to use to create loops. If you really want to solve a problem using loops, then use some other language than t-sql. So you see that it's linear progression, but you have to produce 6-letter strings, which will mean 308 million rows. It takes somewhere around 67 seconds for the tally table approach. For the loop-based approach, it takes 1300 seconds. So it's a huge difference. And even worse, if we look at the recursive CTE solution, it's 2150 seconds or something. So let's put them all together and just see. We have the blue line at the bottom. That is the tally table approach. And the orange one is the recursive CTE, but it's such a huge difference in performance. So if you look at code that is slow because it uses a loop-based approach, and you hear someone argue that, but shouldn't we just upgrade the hardware to make it run fast? This is what you should show them. Show them this graph. How much faster hardware do you need to get the loop-based approach to run as fast as the tally table approach? That's all I had for today. I will share the diagrams. I will also share the code to generate the performance measures so that you can reproduce it yourself on your own computer. Thank you.